In this video, we are going to talk about a different method of solving systems of equations called substitution method. And substitution method is a great method. It's the best method if one variable is already isolated, like this. So you already have a y equals something or an x equals something. Then substitution is a fantastic method. Okay, so let me kind of walk through how you do that. So here we have one of the equations. X plus y equals 15. All right, and then the other equation is y equals 2x. Well, if we know what y equals, then we can take this value and substitute it in to the other equation. Because if that y equals 2x, so does that y. So then we can rewrite that as x plus 2x equals 15. All right, so if y equals 2x, that y equals 2x. So we rewrite it. So that y turned into 2x. And then now we have a very straightforward equation that we can solve. We put x plus 2x together, which makes 3x equals 15. We divide by 3. X is going to equal 5. And then just like any other equation, once you know the x value, you can take and plug it into either of these two equations to figure out what the y value is. I'm going to probably plug it into that one since the y is already by itself. So I would have y is going to equal 2 times the x value that we just found. So you're going to do another substitution. And so y is going to equal 10. So our coordinate is, if we graph these, where would these two lines cross? They would cross at 5, 10. And then I would just do a quick double check to make sure that x plus y, 10 plus 5 plus 10, does in fact equal 15. And so you're good to go. All right, so we could graph it to check it, but we can also just plug it back in, make sure that it works as well. So I want to compare that method with the addition method, which is also the elimination method. They mean one and the same. You're eliminating, but you're also adding the equations together. So in order to do that method, which is totally fine, you can do elimination on every single one of these. You need to line everything up. So right now you have this x plus y equaling 15. We would need to adjust this equation to kind of line it up with this equation. So I would bump the 2x over and make it a negative 2x plus the y. And then there's nothing left on that side, so that would equal 0. So if you did that, you have a negative 2x plus y, and that would be equal to 0. Okay, and then from here we solve it like we normally solve with elimination, is we try to get one of the variables to cancel each other. I do like that one x is a positive, one x is a negative, but I like that the y's pretty much match other than their signs. So I could just take a negative and distribute it to the top equation, which would make a negative x minus y, negative 15, and then negative 2x plus y equals 0. Now we'd be ready to combine. The y's cancel each other, which was good. And then the x's make negative 3x, and the numbers make a negative 15. We would divide by negative 3 to get x by itself, and x would equal 5. All right. Then I would go back and plug in my x either into one of my two originals, and I'd probably go back and plug it into the exact same one that we did up here, where y is going to equal 2 times our x value, which we found to be 5, so y equals 10. So our coordinate of where they would cross without graphing it is 5, 10. So just to kind of show you that elimination you can do most of the time, but not quite all the time. The biggest thing is you got to get a variable by itself. So even if it's not by itself, you can always isolate the y. The only trouble with substitution is sometimes the equations have other numbers attached to the x's and y's that you'll have to divide, and you may create fractions along the way. So if that's the case, I probably wouldn't use substitution just because I don't want to deal with the fractions. Where elimination, you don't typically have to deal with the fractions. Okay, so that was one problem involving substitution. Then we're going to do one more that's a little bit of a bigger problem.